Hi, I'm Professor Angela Rasmussen from the Electrical and Computer Engineering Department at the University of Utah. In this example, we are going to analyze a op-amp and we're going to assume ideal conditions. And then we want to find an expression for Vout versus our inputs. So Vout is located here and our inputs in this case is both VTH1 and VTH2. I'd like you to note that these two circuits are representative of circuits that are coming before that have been changed into Thevenin equivalents. So these could be a lot more complicated circuits that are reduced down to its Thevenin equivalent. So to start this, we're going to make the assumptions of ideal conditions. So the first assumption that is made is that the currents, IP and IN, going into the op-amp terminals are 0. So this is IN, N stands for the negative, and this one would be IP. So both of those are set to be 0. The second assumption is that the voltage at the negative node, Vn, is going to equal the voltage at the positive node. In this case, with the negative side, this node would be our Vn. With the positive side, this node would be Vp. So the next thing is that we're going to try and solve using either node voltage, or if we can use something else as a simple Ohm's law, or just have a direct connection to find Vn and Vp. So we're going to use node voltage to find, in the end, our Vout equation. So here I notice that Vp, if there is no current going through here, there's no voltage drop. That means the voltage here, which is VTH2, is also going to be the voltage at Vp. And that would be my input voltage. So that then, with our assumption of these two, remember these two assumptions are what is needed to be able to solve this circuit fully. So now we know that we can set Vp equal to Vn, which in this case is VTH2. The next thing we're going to do is write an equation for our node at Vn. So the current described in this branch is going to be Vn minus VTH1 over RTH1. This current in this branch going off that node is 0. And this branch current is described as Vn minus Vo. Notice over here that this whole wire is Vo. So that node is Vo. And that's going to be over Rf. And now we can combine those two equations and substitute in the VTH2 to our Vn's here. So I have VTH2 minus VTH1 over RTH1 plus VTH2 over Rf, and then I can take over the V0 over Rf over onto this side. I can divide all of this by Rf and rewrite this equation as V0 is equal to Rf over RTH1 plus 1 VTH2 minus Rf over RTH1 times VTH1. And that is my end equation that describes my output as a function of my two inputs, VTH1 and VTH2. And that concludes my solution.